All right, today we're going to continue our discussion of precursors to evolutionary psychology, and we'll talk about all the topics that you see below: sexual selection, ethology, inclusive fitness, reciprocal altruism, parental investment, and parent-offspring conflict. We're going to talk about them briefly, each one, because they're recurring themes we'll talk about throughout the rest of the semester. So if they don't make a lot of sense right now, make sure you read the chapter. Shoot me some questions, either through Teams or through email. And bring your questions on Wednesday when we will talk about this. We don't have any general lectures going on Wednesday. It's mostly for discussion. So if you have questions about any of this stuff, make sure you bring them on Wednesday. Sexual selection. Darwin was a brilliant dude, but peacocks made him crazy because he couldn't figure out, with the principles of natural selection, how it would be that a peacock would have this adaptation to grow these elaborate displays of feathers when it would be essentially pointing out to all the predators, hey, I'm over here, right? And so Darwin couldn't figure that out from the perspective of natural selection until he stumbled upon the idea of sexual selection, right? So the peacock's feathers are not for the predators, right, obviously, but they're for attracting mates. And so sexual selection deals with the evolution of characteristics due to success in mating, right? So in order to pass on its genetic code, an organism needs to survive, right, survival of the fittest, but it also needs to reproduce. If you're really good at surviving but you don't reproduce, then your genetic code is not going to get passed on. So natural selection, sexual selection go hand in hand with respect to Darwin's theories, right? So sexual selection operates through two different processes: intrasexual competition, so competition with same-sex rivals, and intersexual selection, so being attractive to an opposite-sex mate. Intrasexual competition, exactly what it sounds like, right? So victors in same-sex contests are more likely to reproduce because of increased access to mates. It occurs across the animal kingdom. It occurs in humans. So I'll ask the question, what kinds of traits would be helpful here, right? You're not here to answer, so I'll answer for you. So things you would think of in competition, right? Strength, speed, size, cunning, intelligence, sneakiness sometimes, right? So it depends on what kind of competition you're in. All of these things would help in competing with same-sex rivals for other potential mates. Intersexual selection is essentially being attractive or having attributes that are preferred by the opposite sex. What kinds of things are beneficial here, right? Resources, attractiveness, the ability to produce offspring, all of these kinds of things. We'll talk way more about this with respect to humans, but the important point is that these things occur across the animal kingdom. So Konrad Lorenz and Nico Tinbergen started a movement called ethology. And what they were really interested in was looking at the evolutionary forces that helped to shape animal behavior. So last time we talked about the difference between ultimate and proximate causes, right? So the reason that men and women are of different heights is that men have longer bones. That's a proximate cause. The ultimate cause has to do with all of the evolutionary factors that created this dimorphism between males and females in body size, and hunting and all these other kinds of things we talk about. So Lorenz wanted to look at how evolution influenced these particular behaviors. This was key for evolutionary psychology because no one had really kind of considered this in a kind of organized way before, right? So we're looking at the function of behavior. You'll see the picture here of Lorenz being followed by the ducks, right? So Lorenz discovered imprinting that occurs when ducklings hatch, and they kind of follow around the first thing that they see. Usually it's mama duck, but if it's Lorenz, they'll follow him around too. It's a genetically influenced behavior, and we have them too. William Hamilton developed the theory of inclusive fitness, and it says selection is not just the kind of dependent upon the direct production of your own offspring, but how genetically related you are to family members, right? So it turns out that grandparents have a pretty big investment in their grandchildren. You have, if you're an aunt or an uncle, you share genetic code with your nieces and nephews and cousins. So the degree of relatedness is the thing that Hamilton brought to the table here with respect to inclusive fitness and natural selection. Robert Trivers built on the work of Hamilton and Williams and offered three kind of main ideas that are really important with what we're going to talk about for this semester. Reciprocal altruism, parental investment, and parental offspring conflict. What does that mean? Well, altruism is helping someone out, right? Reciprocal altruism is when an organism will temporarily reduce its fitness. What does that mean? That means it will put itself in danger, perhaps, temporarily, with the expectation that they're going to maybe get something out of it some point in the future, right? So if you run into a burning building to save someone, then you're going to be demonstrating an act of altruism. Hopefully someone would do that for you someday, right? You never know. But with this inclusive fitness stuff that we looked at before, we can kind of determine on a very probabilistic, broad averages kind of sort of way who you would run into a burning building to save, right? So would you be more likely to save your daughter or a stranger? And because of the degree of genetic relatedness, we can make pretty good predictions that it would be your daughter or a family member over someone that you didn't know. Reciprocal altruism occurs throughout the animal kingdom. So you've seen pictures of cleaner fish, right? So these are the tiny little fish that swim inside the mouths of the big predatory fish and pick out the little pieces of food, and the big predatory fish leave the mouth open because they're getting something out of it too. The same thing with the little birds that eat out of the teeth of crocodiles. There are all kinds of cases of reciprocal altruism, and we'll talk about those throughout the semester as well. Parental investment. So if you have offspring, you have to invest at least something in them, right? And parents only have a limited set of resources. So the resources that you are investing in offspring are a cost to your ability to invest in other types of things, right? So if you're investing a lot in your children, then it precludes the ability to go out and make new children. Or if you're investing a lot in one child, it reduces the amount of resources that you have, time, money, food, you name it, to invest in another child. So you have a really good example of this in the bird here. So you see the mama bird, or maybe that's the dad bird, I don't know, is feeding one of the babies while standing on the head of another one. Clearly, there's a favorite here. Parent-offspring conflict comes into place when we have differences in how parental resources should be distributed, differences between the offspring and the parents, right? From the standpoint of the offspring, it's like, I want all of the resources that you have, right? I don't want you to give any to my brother, any to my sister. I want them all. And obviously that's not a viable kind of strategy for parents. So there is a conflict between how much of the resources the offspring want and how much the parents are willing to give. Again, this is something that occurs across the animal kingdom, and we are part of that animal kingdom. Edward O. Wilson wrote a book called Sociobiology, A New Synthesis, and it attempted to kind of put together the key developments in evolutionary biology, right? So what have we learned since Darwin? And he created a lot of controversy in the final chapter on humans, right? Remember that only about 40% of the population in the United States believes in Darwin's theory of evolution. And when he started talking about how it is affecting humans, people just kind of lost their minds. In part because he developed a lot of really interesting and good hypotheses, but didn't have a lot of data to support these at the time. Turns out he was right on a lot of them. They didn't like Edward O. Wilson. Some people didn't. So at a meeting of the American Association for the Advancement of Science, it's a high-level kind of scientific meeting, We had someone who was not really enamored with what he was saying and dumped a pitcher of ice water on him. Now, I don't know if you've ever been to an academic conference, right? This is not the kind of place where people kind of run around shouting and stuff. It's particularly in the 70s, right? Everybody wore formal clothing, ties, or kind of in the 70s probably dresses for women or whatever. But they were really, really obnoxious when Wilson took the stage to speak. They didn't want to believe that their actions had in any way been influenced by evolutionary principles or genetics. So when he would go on stage, they would bring the kind of New Year's Eve noisemakers and bullhorns and just kind of be entirely disruptive. They were angry because they misunderstood what Wilson was talking about. They had misunderstandings about how evolution influences human behavior. So evolutionary theory doesn't say that human behavior is genetically determined and there's nothing we can do about it. It's an influence, right? When we talked about the influence of evolution or genetics versus the environment on our behavior, right? We said that's a really bad question. It's not either or, it's always both. And the amount or the relative contribution of each can change over time depending on the environment or depending on the expression of given genes. It doesn't mean that human behavior is unchangeable. Obviously, the environment and the things that you learn can change your behavior. It doesn't imply improbable feats of computation, right? So when people talked about inclusive fitness theory and your degree of genetic relatedness, well, we know that pretty much that your offspring have about 50% of your genetic code, right? And grandparents know that, well, the offspring of their offspring, their grandchildren, share about 25% of their genetic code. But how much genetic code do you share with your cousin's grandson? Well, just because you can't figure out that math quickly doesn't mean that it's not a contributing factor, right? And it also doesn't mean that the people are calculating the percentage of relatedness and making some conscious decision about, well, I'm 37% related to. They don't do that, right? It's a way of making a mathematical model of how evolution has influenced our behavior, and it certainly doesn't imply optimal design, right? Our behavior and our physiological structure has evolved, but evolution is a very slow process. Evolution evolves for something that works, not necessarily that is the optimal solution. So human behavior is not genetically determined. There's an interaction with the environment and the genes. No one ever said that it was genetically determined. The argument that if it's evolutionary, we can't change it. Well, we can. And some people say, well, we shouldn't even study this stuff, right? Because there's nothing we can do about it. We can do about it. And the more we know, the more accurate we are in how our behavior is influenced, then the better off we can be at changing behaviors that are unsatisfactory or behaviors that we find unacceptable. Our current mechanisms are optimally designed. They're not. Evolutionary time lags. Evolution takes a very long time. Culture changes really, really quickly, right? So we are in a we have these kind of Stone Age brains in a modern technological environment, and we'll have plenty of opportunities to demonstrate this throughout the semester. Just very quickly, the leading cause of death, 10,000 years ago was violence and infectious disease. The leading cause of death today is heart disease. You can't get, when it was difficult to get enough calories to survive, 10,000 years ago, right? So they struggled for survival, and if you found something that had sugar or fat or salt in it, that was very valuable. So those organisms that liked that and found that pleasurable, ate it more so than those that didn't, and they were more likely to survive. And that's why we have the obesity problem that we have today, because food is much more easy to come by than it was 10,000 years ago. But we still have these built-in psychological mechanisms to find things that are sweet and fatty and salty as really good. And so that's just a quick overview of the precursors to evolutionary psychology. And I will see you next time. Bring your questions on Wednesday.